Good day to you, everyone. And how is everybody doing today? I'd like to welcome everyone to today's class, which will be centered on organic compounds and purification and quantification. Now, moving forward, organic compounds and purification and qualification will be discussed thoroughly in this unit. Moving forward, course unit 2.1 and 2.2 will be centered on unit 2.1, which entails purification of organic compounds, and unit 2.2, which entails the qualitative analysis of organic compounds. Moving forward, the course objective are naming of organic compounds, that is the naming of organic compounds. You have to know how to name organic compounds. Purify and quantify simple organic compounds. We all know for a fact that organic compounds are gotten from nature, and they are gotten in form of unpurified. They are not clean. So you have to purify them, and at the same time quantify them. Quantify all the elements that are present in these organic compounds. Now, draw the structure of organic compounds. After these organic compounds have been quantified and you know them, you draw the structure of the organic compound. Identify saturated and the unsaturated hydrocarbons. You have to know the saturated and the unsaturated hydrocarbons that are present in the organic compounds that you are working on. Describe the periodic arrangement of elements, that is on the periodic table. You have to be able to describe the arrangement, how elements are being arranged in the periodic table. That is, how elements are being arranged on the periodic table. Then you have to be able to explain the structure of inorganic solids as well. Mention the basic properties of selected metals. That is, the metal we'll be discussing in this unit, in this course. You have to know the basic properties of this selected metal. Describe qualitative tests for selected metals. That is the qualitative test. That is the quality of these metals. The qualitative test for these selected metals has to be discussed. You have to know them and be able to describe them. Moving forward, let us talk about the study session 2, which talks about how we can purify our organic compounds. As we all know that nature itself is not pure. We know that for a fact. Nature itself is not pure. A lot of method has been devised to tackle this problem. And it is also important to know these purification processes are how they are being carried out. Now, in order to properly understand what method should be applied for a particular purification, we need to understand the types of impurities that can be present or that are present in the organic composition. Now, you see this organic composition, before you can know a particular method that you use to purify them, to make them clean, you have to know the composition of these organic compounds. What are the metals that are present? What are the impurities that are present? You have to know them. Now, on the other hand, quantitative analysis helps to know the number of elements or molecules that is generated in a chemical process. The quantitative analysis helps you to know the number of elements or molecules that is generated or that is gotten in the chemical processes. You see, quantitative analysis entails the amount of any metal or any substance that you can get, or elements or molecules or ions, the amount of them in quantity that you can get in these purification chemical processes. It is important to note that organic compounds is composed of not only carbon element, hydrogen element, oxygen, nitrogen, phosphorus, and halogens are also present in organic composition. Now, moving forward, after the end of this class, what will be your gain? What will you have gained at the end of this study session? Now, you should be able to describe the different types of purification. You should be able to differentiate between simple and fractional crystallization. You should be able to identify the types of distillation. You should be able to explain the principles of chromatography. You should be able to know qualitatively, quantitatively, the differences between them, and learn how qualitatively and quantitatively how you can use it to determine the elemental composition of any given organic sample. That is, when you are given an organic sample, any organic sample you are being given to work on, you should be able to do the qualitative test analysis and at the same time do the quantitative test analysis on them and determine the elemental composition of this organic compound. Now, moving forward, what is the types of design methods? The types and the design methods agreed upon to be used in purification of substances, and they are dependent on whether the substance is in a solid or a liquid form. You see, when you want to use purification processes in purifying organic compounds, you have to first of all know that the organic compound, is it in the form of solid or is it in the form of a liquid? So you have to take into cognizance as well the impurities that are present in the solid or liquid. Examples of such methods are, that is, we are talking about the methods that can be used in purification of organic compounds, are simple crystallization. Simple crystallization. Simple crystallization entails where you use another compound, a particular substance, to crystallize a particular element in form of another compound out of a solution. Crystallization. Crystallization. Then fractional crystallization. That is, to crystallize different elements or compounds in fractions by fraction. Then sublimation. Sublimation. Simple distillation. Fractional distillation. Distillation under reduced pressure. Steam distillation. Azeotropic distillation, and chromatography. All these methods can be used in the purification of substances. Now, moving forward, let us talk about the qualification and the quantification of organic compounds. Now, let's talk first about the qualitative analysis of organic compounds. The qualitative analysis of organic compounds is the analysis of the species present in a given compound. That is, you want to know the species, the types of elements that are present in a particular organic compound. You apply the qualitative analysis. For example, if a compound is taken, that is, when you get an organic compound, the qualitative analysis will be more focused on finding the elements and ions present in the compound. Now, that is, the qualitative analysis will help you know the types of species, the types of compounds, the types of elements, the type of ions, the types of different elements and atoms that are present in the particular organic compound that you want to work with. For example, let us talk about the detection of carbon and hydrogen. You see, the carbon and hydrogen can be detected when you eat a particular compound with copper 2 oxide. When you eat a particular compound with copper 2 oxide. Now, you see, this copper 2 oxide in a dry test tube, when you eat it up in a dry test tube, remember that this carbon and hydrogen will be oxidized to carbon 4 oxide and water respectively. They will be oxidized to carbon dioxide and water respectively. You see, knowing for a fact that oxygen is a very good oxidizing agent. Oxygen is a very good oxidizing agent. The oxygen in the copper 2 oxide will oxidize carbon and hydrogen respectively to carbon 4 oxide and water respectively. To carbon 4 oxide and water respectively. Now, to now let you know that carbon and hydrogen is confirmed. If the carbon 4 oxide turns lime water milky and water turns anhydrous copper sulfate to blue color, then the conformation of carbon and hydrogen is sustained, is held. Carbon and hydrogen is present when the carbon 4 oxide turns lime water milking, and water itself turns anhydrous copper sulfate to blue color. Then it confirms the presence of carbon and hydrogen. Then let's talk about the test for phosphorus. You see, when you want to test for phosphorus in a particular organic compound, you weigh that particular organic compound and you heat it up. You apply it with it in the presence of an oxidizing agent, so that the oxidizing agent will oxidize the phosphorus to phosphate. The oxidizing agent will oxidize the phosphorus to phosphate. Now, the solution now will be boiled together with concentrated triazonitrate 5. Concentrated triazonitrate 5. And you will treat it with ammonium molybdate. It will be treated with ammonium molybdate. Now, yellow precipitate will confirm for you the presence of phosphorus. A yellow precipitate that will be formed will confirm for you that phosphorus is present inside this solution, the organic compound. Now, let us talk about the quantitative analysis. The quantitative analysis of organic compounds. We have first of all talked about the qualitative. The qualitative will let you know the types of species that are present. While the quantitative will let you know their amount inside the organic compound. Now, the quantitative analysis is more towards finding out how much of the elements are present, that is, their amount. Let us talk about the estimation of carbon and hydrogen using the Liebig's combustion method. Now, when you weigh a certain amount of the compound and you heat it up with copper 2 oxide, the carbon present is oxidized to carbon 4 oxide. The carbon will be oxidized to carbon 4 oxide. Remember, I said oxygen is a very good oxidizing agent, while the hydrogen will be oxidized to water. Now, the carbon 4 oxide will be absorbed in a potassium hydroxide solution. That is, potassium hydroxide will be used to trap the carbon 4 oxide, while the water will be absorbed by anhydrous calcium chloride. And you weigh them. That is, you weigh the carbon 4 oxide form and you weigh the water that is formed. After weighing them, you record the mass. It will be represented as the mass of the carbon 4 oxide and the mass of the water. Now, to now calculate the percentage of carbon, it will be the molar mass of the atomic mass of carbon divided by the molar mass of carbon 4 oxide. That is, the molar mass of carbon 4 oxide multiplied by the mass of the carbon 4 oxide that you have weighed over the mass of the compound. This compound that we're talking about is the initial compound that was heated with copper 2 oxide. Then you multiply it by 100%, since you are calculating in percentage. Now, to now calculate the percentage of hydrogen, it will be the atomic mass of hydrogen, which is 2, divided by the molar mass of water, which is 18, multiplied by the mass of water that you have weighed, that is the mass of water that was absorbed in the anhydrous calcium chloride, divided by the mass of the compound that you started with, the mass of the compound that was heated with copper 2 oxide, multiplied by 100%. That's how you calculate the percentage for carbon and the percentage for hydrogen. Now, moving forward, the estimation of halogens using the Curious method. The Curious method is very, very important because it has been used to estimate halogens, the sulfur, phosphorus, and so on and so forth. Now, let us talk about the Curious method as applied in determination of halogens. When you know a known mass of the compound, that is organic compound, will be weighed and you heat it with a corn triazonitrate 5 acid in the presence of silver nitrate. In the presence of silver nitrate. And what is the whole essence of silver nitrate? Is to act as a precipitator. Is to act as a precipitator in the solution. Now, you heat it up in a Curious tube. Now, carbon and hydrogen will be oxidized to carbon dioxide and water. The halogen forms the corresponding silver X. The halogens will form the corresponding silver X, where your X can either be chlorine, fluorine, bromine, and so on and so forth. Now, it is then filtered, dried, and weighed. It is then filtered, dried, and weighed. Now, let's talk about the estimation of sulfur. The Curious tube is used as well in this process. The known amounts of compound, is weighed. You weigh the compound. You record the mass. Then you now eat it with concentrated triazonitrate acid in the presence of barium chloride solution in a Curious tube. Sulfur will be oxidized to tetraoxosulfate 6. Sulfur will be oxidized to tetraoxosulfate 6 and will be precipitated out as barium sulfate. Because of the barium chloride that was present in the solution initially in the Curious tube, it will be precipitated out as barium sulfate. Then it is dried and you weigh it. Now, the percentage of sulfur, how you calculate the percentage of sulfur will be the atomic mass of the sulfur divided by the molecular mass of the barium sulfate that was precipitated out, multiplied by the mass of the barium sulfate. Mass of the barium sulfate, that is the mass of the barium sulfate that was precipitated out, then over the mass of the compound. The compound we're talking about is the compound that was initially started with, that is eaten up with the conc triazonitrate 5 acid. Now, how do you estimate phosphorus? How do you estimate phosphorus? Phosphorus can be estimated by eating the compound. A known mass of the compound is eaten up with triazonitrate 5 acid in a Curious tube as well. In a Curious tube, which will now oxidize the phosphorus to a phosphoric acid. The phosphorus will be oxidized to a phosphoric acid. Now, you now heat it up with ammonium molybdate. Ammonium molybdate is heated up or added to it, which should then be precipitated out as ammonium phosphomolybdate. It will be precipitated out as ammonium phosphomolybdate. You filter it, you dry, and you now weigh it. That will give you the phosphorus that you. Now, how do you calculate the estimation of nitrogen? This one can be done by Dumas method, where you will weigh a certain amount of the compound and you heat it up with copper 2 oxide in the atmosphere of carbon 4 oxide. That is, carbon 4 oxide is present in the heating up of the certain compound, which will now give you nitrogen along with carbon 4 oxide and water. Nitrogen along with carbon 4 oxide and water. You see, all these products that are formed, the gaseous will contain a gaseous mixture. That is, the product that is formed will contain a gaseous mixture. Now, this gaseous mixture comprises of carbon 4 oxide, nitrogen, and as well steam. The gaseous mixture, the carbon 4 oxide can be collected. That is, the gaseous mixture is collected over potassium hydroxide, and this potassium hydroxide will trap or absorb the carbon 4 oxide, while the nitrogen will be collected in the upper part of the graduated tube. The graduated tube has an upper part that will be used in the collection of nitrogen. Now, the digestion method. The digestion method, that is the protein. Digestion means the protein, whereby it is done in a Kedal digestion flask containing, this digestion flask contains a 98% tetraoxosulfate 6 acid. Tetraoxosulfate 6 acid. And you will eat it up for 2 to 3 hours. Nitrogen will be released from the organic material and is present and is present in the digested solution as ammonium tetraoxosulfate 6. That is, the nitrogen that is released from the organic material is present in the digested solution. The digested solution that you have digested, you know, when you digest the protein, the digested solution contains nitrogen in the form of ammonium tetraoxosulfate 6, as shown in equation 1. Contains nitrogen in the form of ammonium tetraoxosulfate 6, as shown in equation 1. Now, the equation 1 will be distilled to determine the nitrogen content in the digested solution. Remember, the digested solution contains ammonium tetraoxosulfate 6, as represented or shown in equation 1. Now, that confirms the presence of nitrogen there. Now, the distillation processes now entails the determination of nitrogen content in the digested solution. Now, concentrated sodium hydroxide, that is 30% concentrated sodium hydroxide, will be added to the digested solution. Ammonia will be generated as represented or shown in equation 2. Look at the equation 2 very well. Ammonium tetraoxosulfate 6 plus the sodium hydroxide will give you your ammonia, sodium tetraoxosulfate 6, and water respectively. Now, the ammonia that is generated in equation 2 will be distilled in equation 3 using a boric acid solution. A 2% boric acid solution. Now, the ammonia from equation 2 will be distilled in equation 3 in the presence of boric acid solution, 2% boric acid solution, as shown in equation 3. Now, the titration will be done, which is the final step. The titration, that is ammonium tetraborate that is formed from equation 3, will be titrated with hydrochloric acid. Will be titrated with hydrochloric acid to give you your ammonium chloride and the ammonium chloride. Now, that ammonium chloride formed will be, now if you now want to calculate the percentage nitrogen from equation 4, it will be the titer value. The titer value you've got it from equation 4 in mils multiplied by a factor, and the factor is 0.00056 multiplied by 6.25 divided by the sample weight. The weight of the organic compound you weighed initially, multiplied by 100%. That will give you your percentage nitrogen. Distinguished learners, from what we've discussed so far, I want to assume and presume and believe that you have gained one or two. And when you read up the notes being forwarded to you, you should be able to gain, and during discussion or discussion sections, more things will be gained from both ends. Thank you for your time. And I want to sincerely thank you for listening to this class and lecture. Thank you.